We're starting chapter 5 today, and chapter 5 deals with functions. Have you guys had any experience with functions yet? Okay. So the simplest way to explain a function is to show we do this. We say this function's name is f, and we draw something like this, and we call this first circle the domain. And then the second circle we call range. And then a function just connects some part of the domain with some part of the range. So I could put numbers in here, 1, 3, 6, 2, 5, 1, 3, 8. And then we just draw lines to connect them. Okay? And what that means is, if I am function f, and you tell me the number 1, then I return to you the number 5. So 1 is connected to 5. 3 is connected to 3, 6 to 1, and 2 to 8. And you can represent it as a table. So as a table, it would look like this. So this is f. Here's my domain, and here's my range. I would list 1, 5, 3, 3, 6, 1, and 2, 8. It can also be listed as a set of points. So 1, comma 5, 3, comma 3, 6, comma 1, and 2, comma 8. It could also be listed in a graph. So 1, 5, 3, 3, 6, 1, and 2, 8. So these points represent a function. Yes? So some things are not functions, and that's what we need to figure out first. But those are the 4 ways to represent a function. But if you just throw random numbers up there, you do random connections, there is one rule that functions have to obey. And if it breaks that rule, then they are not called functions. And before I get there, a lot of things might not be part of this function. So if I have listed function f and you ask me, what do you do to the number 5? There is no 5 in the domain. So you tell me 5 and I say 5 is not part of the function. There's no range associated with that. Okay? So what do we do? How do we tell if something is a function? So let's say we're now looking at function g. And we have Hannah. What city do you live in? Castledale? So Hannah is attached to Castledale. Kason? Okay. Tyson? We're going to run out of room. Long way. Jersey? What? Okay. Landon? Oh, sorry. Geez. Landon. Man. Eventually we're going to run into one that will help us with what we're going to do. Garrick? Oh, jeez. Okay. Olivia? What? Okay. Okay. So, all right. We finally found one. So let's do Turner. Turner, where are you? What are you? Okay, so Turner. Yeah. All right, so this is a function that connects a person with the city they live in. Okay? And this is a function, but you'll notice that the domain is bigger than the range. Okay? And there are some cities that have multiple people in them. So here's the rule for a function. No person can live in two cities at the same time. Okay? That's the rule. No person can live in two cities at the same time. Okay? And typically when we talk about functions, we call this first one x and the second one y. And the rule for a function says, you paying attention? No. The rule for a function says no x is connected to two y's. But you're going to forget that. So the way you remember it is no person can live in two cities at the same time. Right? That physically can't happen. You cannot be living in Huntington and at Farron at the same time. Well, you could live in one, right? You could be in one, but not the other one. It's not possible. Okay? So, how do we determine if something is a function or not? So if I had this, is that a function? Yes. If I had this, is that a function? Can everybody live in Orangeville? Yes. Is that a function? No. Because Garrick claims he lives in Castledale and Orangeville at the same time, and that's impossible. Do you guys understand that? No x can be connected to two y's. No person can live in two cities at the same time. So what do we do with that? Well, let's say I listed a function like this. Is that a function? How do we check? We could draw it out, or we could look at it. There are no duplicate x's. Okay, what if I did this? Yes. Is it still a function? Careful. All I did was listed 2, 6 twice. So we look for the rule, is any person claiming to live in two cities at the same time? No. But if I went like this, now person 8 claims to live in city 3 and city 4. Okay, what if I did this? Is that okay? But I have 2 3s. Right. Can multiple people live in the same city? Yes. Okay. So, what about a graph? Is that a function? Colin, pay attention. Is that a function? No. Why? 2 x's, so 1 x has 2 y's. Which 2 points? These. So this point here is 2, 3, and this point here is 2, 4. So instead of having to be really careful and looking at all the numbers, what is it about those 2 points that tells you that it's not a function? They're on the same vertical line. Okay? So, in function notation, we refer to this as the vertical line test. The vertical line test says, if you draw a vertical line, that's not very good, and you move it around, does it ever hit 2 points at the same time? Right there. Okay, so if I had a graph like this, is that a function? Can I draw a vertical line and hit it more than once? No. So that is a function. Okay, what about this? No. And we say that line fails the vertical line test, so it's not a function. In fact, if we slide this over, one person is trying to live in 3 different cities. Okay? What if I had a line like this and a line like that? Nope. Fails the vertical line test. Okay, what about this? That passes the vertical line test. What about a circle? Fails the vertical line test. Okay, so let's look at some examples. Relation 1, is that a function? Yes. Is any person trying to live in 2 cities? No. Okay, relation 2? It is. Okay, the only way it would not be a function is if one of these had 2 lines, and none of them do. Okay, what about relation 3? JF, JJ, JX, JA. Definitely not. Okay, relation 4. Yes. Okay. All right. Is graph 1 a function? No, because fails the vertical line test. 2? No. 3? Yes. 4? No. 5? Yes. 6? No. 6 fails the vertical line test right there. So if you would have been paying attention, that's failing. Because they're right on top of each other. Okay, here's number 3. 3 wants to know, what is the domain? So we just list all of the x's, but see these funky parentheses? You have to use these funky parentheses. So what is the domain here? -1, 2. Okay. Do I need to list the 2 twice? No. Okay. Now, if it's not a function, what do we call it? It does work? Okay. It's a relation. So actually, everything that connects x to y is a relation, but functions are ones that don't put a person in the same city. Okay? And then for the range, you're going to do funky parentheses, 3, -6, 8, and -1. Okay? All right, number 4. X is domain. Okay. What is this asking you to do? So it wants to know, if you say -4, what does the function say? So we put -4 in there. 2 times -4 minus 5. That's -8 minus 5 is -13. Is this a function? How do we know this is a function? Okay, if you know what the graph looks like, it's a line. But here's the question. If you pick an x, will you always get the same number when you plug that x in? Yeah. So if I say 2, if I keep plugging 2 in over and over and over, am I going to get a number that's the same, or will it change? It's going to be the same. Okay? So, just for your information, if you have an equation with x's in it, it will always be a function. So, and this is good to know, f of x means y. They're the same thing, just in a different notation. If you have a y equals equation, it will always be a function every single time. The only way to make that not a function is if we had something like this. If the y is squared, then it may or may not be a function depending on what's going on. But if you have y equals x equation, that will be a function every single time. Oh, and by the way, this is a dead giveaway. If they call it f of x, it's a function. It has to be. Then it's a function. Yep. Yeah, if you have an equal sign and then an x equation, it's a function every single time. Okay. Number 5. So here you're going to plug 7 into the f equation and -5 into the g equation and simplify. And then this is the hardest question. What does this want us to do? Wants us to plug 3x in for x. So here's what the equation looks like. And where the x used to be, it wants you to put 3x. What does it say? Okay, I'll do one of those in a second. So this simplifies to be 3x plus 7, and the bottom becomes 6x plus 3. Okay, now let me find one that's a little bit different from that. I don't know that it's less challenging. Maybe it's not going to give me one. Here we go. So I have my function that says -5 plus 2 times something divided by 6 plus something. And what is the something I'm plugging in? X plus 5. So I distribute. On top, we get -5 plus 2x plus 10. And on bottom, I have 6 plus x plus 5. And then we just combine like terms. So the top will be 2x plus 5. And the bottom will be x plus 11. What about 10? Where are you confused? Yeah, so this and this turned into a 5. Oh. Okay. Does that make sense? Should be a pretty easy day. Get to work.